Hello, this is Math with Beth, and I'm going to show you derivatives of a to the x and log base a of x because they have two special formulas. So this is showing you that the derivative of a to the x, so that means a number raised to the x, equals, this is ln a times a to the x. So I'll show you what that would look like. So if I was doing 2 to the x, the derivative would be ln2 times 2 to the x. That's it. So for the second one, it would be ln 1.4 times 1.4 to the x. So now let me show you a little more complicated one that would involve the chain rule. So for this one, my first is dealing with the 3 to a power. So that's going to be ln 3 times 3 to that power. But because this wasn't just an x, I have to do the chain rule, which basically just means multiply by the derivative of that. So first I handle the main idea, 3 to a power, which I just did, but then times the derivative of that, which would be 2. So basically, you could make this a little nicer and put all of this together times 3 to the 2x plus 1. That's it. So now how about if it's a log with a certain base? Log any base of x turns into 1 over ln a, so whatever that base was, 1 over ln that, times 1 over x, which basically means you can just always go to here. 1 over x times ln of that base. So let me show you how easy that is. So log base 8 of x, I'm just going to make it 1 over x times ln 8. That's it. So for the next one, there is no base, but that really means 10, right? If there's nothing there, it's a little 10. So this would turn into 1 over x ln 10. Again, let me show you some more complicated ones though, but that is the main idea. But here is again going to involve the chain rule because it's not just log base 3 of x. It's something more complicated. It's a function inside a function. So you need the chain rule. So all you have to do is add that one extra step at the end. So first, this would become 1 over, so instead of just x, it would be x squared plus 1 times ln 3. So that's me just doing this formula. It's just that there was something more than just an x. But now we have to multiply by the derivative of that. That's the chain rule. So you can rewrite this as just one fraction with the 2x on top, the x squared plus 1 times ln 3 on the bottom. So just like all derivatives, they can get pretty complicated when you add chain rules or product rules, stuff like that. So let me do one more example, and this one is the product rule. So do you see that this is two separate functions that have x's? So that's how I know I need to do the product rule. And hopefully you know the product rule. Otherwise, there's a video on that. The product rule is you take the first thing and keep it the same, but you multiply it by the derivative of the second thing. So that's where I'm going to use this new formula to get 1 over x ln 5. But then you add the second function as is times the derivative of the first. So that would be 3x squared. That's it. So this is my first function times the derivative of the second one plus the second function times the derivative of the first. This can't be much nicer, but you can definitely put these together. So if you put the x to the third on top of this, you could even reduce it to x squared over ln 5 plus the 3x squared would probably go in the front just to make sure you know that it has nothing to do with the log. And that's it. So this is the two new formulas and how to use them even in some of the more complicated equations. I hope that helps. If you need more examples, just let me know.